Welcome back, chemistry fans. Today we get the opportunity to make some corrections to our Unit 3 exam. So we're going to start right away here. We're going to jump into the free response portion of it. So we're starting with question number 19. Let me share with you my screen so we can do these. Now, this one is very challenging. There were very few folks who got all of them right. So what happens in this is that you have an element and it has a mass number. We'll deal with that later. Right now, we need to figure out what element it is. It says that in the first row, there are 2 electrons. In the second row, it says there are 8. No surprises so far. Then it says, well, you've only got a certain number in the third. You've got 11. It says nothing about the fourth. This is a violation of Hund's rule. This is a violation of the octet rule. So what we've got to do is figure out, well, why did that happen? It lost 3 electrons. You can't simply just add them to the third. What we need to understand, if we are looking at our periodic table, right now, if we add all of this together, we're at 21. It lost 3 electrons. Simply stated, it was at 21 currently. It lost 3. It's chromium. That's the element. If it was at 21, it lost 3. That means it needed to add 3 more to it to make it into chromium. Now, where do we get the values that were given to us? Okay, so 2 on the first, 8 on the second. Now for the 11, we have 3 and 6, that's 8, and then 8, 9, 10, 11. So it lost this 12th electron in the 3Ds, and it lost 2 electrons in the fourth. So I will highlight the ones that are lost. So those are the 3 that are lost. So what is left over is what is on the board now. So now that should help us as we are trying to count our electrons for the remainder of this question. So getting back to the root of the question, what element is this? What is its atomic number? Its atomic number is 24. It's element number 24, chromium. What is the total number of S's? Well, we have 2 on the first. What is the current total number? So we have 2 in the first, 2 in the second, and 2 in the third. That is 6. Now, we originally had 8, but we only have 6 now. The number of P's. You don't have any in the first. You have some in the second, and you have some in the third. That would give you 12. Now, for the D's, the current number, remember the current number is what we're looking for. So to get to the current, what we're going to have to look for is how many are in the D's currently. There are 3 in the D's. We lost 1 that has been shaded out. We are back to now having just these 3 right here. This fourth one has been lost. So we have 3 of the D's. All right, so let me see if I can go back to our page. All right, so let me scroll down. D's, we have 3. Current number of neutrons. All right, well, the mass number is 50. We know it's element number 24. That means that this number should be 26. The current energy level for the valence electrons. We don't have a 4th energy level anymore. So all we have valence electrons for are the 3rd. All right, moving on. Modern periodic table. Why does the size get bigger as we go down the periodic table? 2 simple words. Energy level. If I saw that, I give you full credit. But what you need to know is that it adds more energy levels as you go down the periodic table. Okay, question number 21. Now, this question is asking us, why does it get smaller as it goes across the periodic table? And I detailed this many times in class. There are 3 parts to this. Part 1 is no new energy levels. Second part is that we increase the number of electrons and protons. And the third part is that there is magnetic attraction between the protons, magnetic attraction between the protons and electrons, and that causes them to stick together. All right, number 22, what proof do we have that all of this electron configuration stuff is true? 3 simple letters. The PES graph, the photoelectron spectrum graph, is how we know that it is true, because we have data that backs it up, and I will refer to that whenever we get to it on the subsequent questions coming up here. What does the 1, the S, and the 2 stand for? The 1 stands for energy levels. The 2 stands for sublevels, and the number up above, that stands for the number of electrons. All right, moving on. If we were to look at these 2 graphs, what element is this? Well, I'm going to start with number 25. You start with the highest value. This is larger, 647 is larger than 0.9, so this is the 1s2. Then you go to the next in your electron configuration, 2s2, 2p6, 3s2, 3p6, and this is 4s2. If I add up all of those values together, I get 20. That is calcium. All right, this is everything that I think. I don't know if there's one more. Hold on, let me see if there's one more set of questions. No, that's it. So this is everything that I wish to share with you about free response questions. Thank you so much. Talk to you again soon. Farewell.